So, Barta, thank you very much for doing this today, doing the interview. We appreciate you taking your time out from the convention in Vancouver to talk with us. And I gather that you have your expertise is around utilities and electric vehicles, the electrification of transportation. So, we want to talk today about charging infrastructure in Europe and how that will have an effect on the European utilities, on the grid, as it were, as we go forward with more and more of these EVs. Could you give me kind of an overview, your take on that issue?
Well, I work at ELAAD. ELAAD is a collaboration of Dutch DSOs and TSOs. And the Netherlands, the Dutch government has set ambitious goals for climate, but also electrifying transportation. So in 2030, all new sold cars must be electrified or zero emission. And in 2025, the buses must be electrified. So quite ambitious. We only have 10 years to set the infrastructure needed for charging all those vehicles. Right. And we're doing that together, not only as a DSO installing, connecting the charging infrastructure, but also a lot of planning together with engineers. And as I mentioned today at the conference, make the vehicle a component of the grid. Vehicle is grid.
We'll talk about that in just a second. I often get asked, because I write about electrification of transportation quite a bit, so I often get asked by readers, can the electric utilities keep up with the growth of the electric vehicles? And then by that, not only power generation, but also distribution. Can they put in place enough updated equipment to handle all of that draw on the system as the demand grows? What's your take?
Very interesting question. I think you can manage, but not all at the same time. If everybody comes home at 5 o'clock and starts charging, you definitely have a big issue. However, not everybody needs the car at 8 o'clock in the evening again. So you can delay the charging during the day or charge at night when there's a lot of capacity. The grid has so much capacity at times when we use our
We're back.
Yeah. Okay. Well,
can I get you to start over with, you were saying we have so much capacity at night when the grid, there's no demand on it, and then you broke up. So if you could just start there, please.
Yes, we have a lot of capacity at night, for example. So if you just delay the charging, electricity prices often become lower. But the electric car also can be a solution. In the Netherlands, we install a lot of solar panels. They give a supply peak during the day. And we have to install a lot of cables for transporting that supply, that energy. And if you can store it in the car or harvest it during the day, you don't need the investments for shaving the supply peak.
One of the points that gets made occasionally by experts when we're talking about this is the role of enabling technology. So we'd be software and artificial intelligence, machine learning. Is that really critical to making this complex system work, where you're drawing when you need to, you're integrating the EVs into the grid storage? How important is that enabling technology?
It's very, very important to let the car talk to a solar panel. You need communication protocols, and it is the vision of us, of ELAAD, that these protocols should be open, not only open to download, but also open development. Not only development by the grid operators, also the automotive, the energy sector, because we're the founder of a protocol called OCPP, which is de facto becoming a world standard in vehicle and grid communication. But in the early days, it didn't have features for cybersecurity or payment or all that type of stuff. So there's a lot of stuff to develop. That's fun, but we shouldn't develop it the traditional way in one sector. New standards should be developed cross-sector with knowledge from automotive, together with grid operators and energy suppliers, even banking sector.
When I get into discussions, especially with folks in the oil and gas industry, and they're wondering how quickly electric vehicles can be adopted and displace gas-powered engines, we say, well, how fast can this development take place? How fast can you do protocols, install infrastructure? And I'm impressed by, and I think we underestimate the commitment of the utilities, of the policymakers, and so on to get this done in a hurry. Is that the case over in Europe?
Yes, definitely the case. Not only the climate issue is driving the cost, also a newspaper in the Netherlands was the headline, 20% of our youth has asthma because of noxes. And another thing is the heating of our houses is done by natural gas, but we pumped up so much gas that we had earthquakes. So heating of houses is abandoned, and we have to electrify the heating of houses. So it all multiplies. There's a big push on the energy system, and there comes the saving angel, the battery of the car, because then it can store energy and well help balancing the grid.
One of the things that surprised me is the rapidity with which EV batteries have developed. So it was not that long ago, and it was last year, we were talking about $135 a kilowatt hour. And now the rumors are that Volkswagen has actually, through economies of scale, achieved under $100 a kilowatt hour. So it seems that battery, not so much battery technology, but battery design, battery manufacturing is advancing very quickly, and more of these batteries are going to be available. Is that kind of your impression as well?
Yes, economies of scale are tremendous. I'm not a battery expert, but I see cars getting cheaper and cheaper. But also, my expertise is charging infrastructure, and we have to roll out a large amount of chargers. And doing just one charger at a time was quite expensive. The engineer had to get there, make an appointment, municipality to get a permit, a lot of administration, a lot of time lost. And now we're rolling out in large batches. A street or a neighborhood gets multiple chargers at a time. So the process is much more efficient. You're buying not one charger at a time, but you buy, say, 500 or 1,000. So also in engineering and big tenders for municipalities, economies of scales are also applicable. And this, together with the reduce of costs and the improvement of quality of electric cars, will give a big push on the rollout, in my opinion.
I interviewed an EV analyst from London last month, and they had just completed a survey of American attitudes towards EV consumers and their attitudes towards buying electric vehicles. And he made the point that it used to be that the purchase price of the electric vehicle was the number one constraint to buying. And that's no longer the case. Now it's dropped down to three, and the one and two are now range of the battery and availability of charging infrastructure. Is the same kind of attitudes on consumers, is that happening in Europe as well?
Yes, and another thing in the Dutch are quite on the penny. A second-hand value of your new car is also very important. If you buy a diesel drivetrain now and you want to sell it in, say, 5 years, in 2024, 2025, all municipalities have environmental zones, and you can't enter the cities anymore with your diesel drivetrain. So nobody wants to buy your second-hand diesel anymore. So it's not only the good things of or the constraints of an electric vehicle, like range, price, and availability of infrastructure, it's also become a constraint of the diesel drivetrain that, yeah, it's not so popular anymore. And in 2025, nobody wants it.
Well, now you're an expert in charging infrastructure. How quickly can we charge an electric vehicle battery these days?
What we do is AC charging. Every charger can do 11 kilowatts per hour. Um, so that's if you have a Tesla and it's totally empty, it will take you a night. But normally, with the distances driven in the Netherlands, we're a small country, maximum you do at a day is 50 kilometers. So in in 1 or 2 hours you get a full battery again.
Is there tech?
And of course we have a large fleet of fast chargers where you can go much faster, and we see a trend from 5 years ago, 50 kilowatt chargers installed now to 150, even some 300 or 350 kilowatt hours per charger. Really fast.
That's what I wanted to zero in on, was the fast charging. So now I understand that that also requires some changes to the battery to work with the fast chargers. But assuming that that's the trend, how fast will those batteries charge?
Well, for personal vehicles, I don't think there's a race to the bottom. At a certain moment, you like to, um, uh, in our opinion, we see 85, 90% of the charges made will be at the office or at home, somewhere in the street with a MERP or so only 10% will be on your way to an appointment along a big highway. For cars, well, no race to the bottom. For heavy-duty trucks or buses, I think there's convenience or also a business case to the faster you can charge, the better you're off. But on the other hand, buses and heavy-duty trucks also spend a lot of time at night in the depot. And well, there shall be an optimum between installing fast charging infrastructure, which is quite expensive, or charge your car at the depot at night, or a car, I must say, a bus or truck at night, with much cheaper charging infrastructure.
When I started reporting on electrification of transportation 5 years ago, the sources that I was interviewing, we were having conversations that were very basic, about costs of batteries and those sorts of things. They were much higher and so on. But now, 5 years later, we're having these we're discussions about much more complex issues and how to integrate things and how fast can we do them. And, it's like the adoption rate has climbed up on the S curve, and we're very close to that, where the blade meets the hockey stick, and we're very quickly going to be seeing rapid adoption. Is that your impression as well?
Yes, I think we're reaching the tipping point. Um, Maybe not in 2020, but 2021 definitely, where an electric car is the same price as a traditional car. And that, well, as I mentioned, the Dutch are on the penny. That will push the market very much. But it's also good for the system, because if you do it on a smart way, you can combine a lot of trends, solar panels, electrified heating of houses, and it all comes together the coming 5 years.
Will, as you electrify transportation in conjunction with electrifying home heating and industrial processes and so on, can power generation, especially from low carbon technologies like wind and solar, can it keep up?
Yeah, we must. It's not, can we, but work harder, in
So
my
that's
opinion.
So is there a commitment in the European countries that come what may, they will do it one way or another, invest their
Yeah,
capital?
yeah. And capital, of course, is a big thing, but also engineering capacity. That is our bigger concern. So we try to plan together with municipalities and car manufacturers. Where are your batches of cars or trucks or buses are going to come, so we can prioritize certain locations, because an engineer can't work on a solar panel and a charging station and a DC fast charger on the same day. There is a constraint on labor at this moment, and which is also good, because people with distance to the labor market are now educated by us to become an engineer. Elder people, new immigrants, people with difficulty, for more prisoners. We try to educate them and make them engineer, so they also have a better future,
Well, it's
a side
fascinating.
a side effect.
Baerte, thank you very much for this. This has been terrific. I appreciate your interview, and we'll look forward to catching up with you again in the coming months.
Nice. Thank you very much. Bye bye.